Okay, let's start. Uh, uh, okay, so first thing we need to know here is what is Spark first of all. Okay, so just show some prompts. Okay, so you can see here Spark is fast distributed computing framework abstracting internal details for the developer. Okay, so it is for distributed computing. Okay, okay. You can compare it with Hadoop's MapReduce. Okay, you can not have write notes. I mean, this is available too.
Okay, this is
Oh, everything is available. You can open the link. Okay. So you can compare it to Hadoop's MapReduce. Okay, what is Hadoop's MapReduce? MapReduce is a distributed computing framework. Okay, Spark is alternative to that. It is faster. You can see Spark is 100 times faster than Hadoop. Okay, and it is faster and it is easier to write. They typically want people from different background to be comfortable writing code here using Spark. Who shouldn't join? I sent him the link. Okay. So the next aspect is what is PySpark doing here? Understood, right? What is Spark? It is an alternative to Hadoop's MapReduce, and it is a fast computing framework. And Spark is actually in two versions, 1.6 and 2.x. Okay.
So which version is more?
2.0, 2.x, and that is what we'll be studying here. Okay. So understand, to work on Spark, you don't have to know what is happening internally. You just have to know good programming. So that is what is PySpark. Many data processing people are using Python. Okay, and actually, frankly speaking, I've done all and in a very small amount of time. Okay, there was IBM training which happened in PySpark. Okay, they are planning third training on PySpark. Okay, so you can understand how much these companies are using it. There is a data processing. So all the ETL developing companies, right?
Mostly many of the companies prefer Hadoop and MapReduce.
No. Hadoop and MapReduce is old school.
Okay.
Okay, so those are little. I mean, if you are writing MapReduce code, something that will take you 2 lines to write in Spark will take 100 lines to write there.
Yeah, exactly.
Right. So it's not. See, companies who are using Hadoop might want to do that. Okay, but a lot of companies have migrated from Hadoop to Spark. Okay, typically because it eases out developer to write complex code. Okay. So for data processing companies like any finance companies, Cabbage is one company where I did the training. Right? They typically are data scientists. PySpark is very popular among data scientists. Okay. So computation power limits to the skill. PySpark comes as a survivor, cuts down coffee time. Every time you execute something, the thing is, you understand what is distributed computing, right?
Yeah.
Okay. So every time you do something, you're making use of multiple computers to do the stuff. So that is what your PySpark is doing. Okay, Python is easier language to learn and huge community support. Anything that you are stuck in, you will find a huge community support helping you out. And its APIs are very similar to Pandas and Scikit-learn. Pandas and Scikit-learn are machine learning libraries. Scikit-learn is a machine learning library in Python. So whatever machine learning you do in Spark, right? It's very similar to what you do in Scikit-learn. Okay, so somebody who knows Scikit-learn can very easily learn this thing. Then and
what about Pandas?
Pandas is like data cleaning, data processing, data munging. All this thing is done using Pandas. And here the APIs is very similar to that. So if after you learn this, right, you can learn Pandas and Scikit-learn. Okay. So these are various components of Spark. Right. One is your Spark SQL. One is your Spark streaming. One is your Spark MLlib. One is your graphics, and one is your Apache. Okay, it runs Spark. The beautiful part about, so what are these things? Spark SQL is like, SQL, right? It provides you SQL type of interface. You can write SQL commands on Spark. You don't have to write equivalent MapReduce code. You can write SQL command on Spark. Then you have Spark streaming. Okay, I'll explain. Spark streaming means you are getting live data, Twitter data, live stream data you're getting. This guy can process and compute that. Then you have MLlib. Okay, what is MLLib? Spark machine learning library. Spark is extensively used for machine learning. Okay,
How is it used?
how it is useful, right? So because machine learning is very much computation intensive. Okay, machine learning is very much computation intensive, and Spark can enable your computation across multiple machines because it can do distributed computing for you. Understood, right? So leveraging multiple systems, you can make use of Spark ML. Okay, graphics or graph frames, actually it is graph databases. Don't worry much, it's very new and still less companies have adopted. Okay, I won't really discuss much with this. And this is your Apache Spark framework sitting on bottom of it. And Spark talks to Hadoop, HDFS. Spark can read data from HDFS, write data to HDFS. So it can be a simple replacement to Hadoop's MapReduce. It can Mesos is there, Apache HBase is there, Cassandra is there, Hive is there, right? Your local file system is there. Spark can make use of that. Okay, this is how the course will proceed. First, you will understand what is Spark and all. Then you will understand what is RDD. RDD is the core part of Spark. Okay, so now we have typically done this thing.
What is the combination you
A
have?
resilient distributed data set. Okay, so this is like heart of RDD, a heart of Spark. Okay, this is heart of Spark. Then you have DataFrames. DataFrames is like which a new addition to 2.x. Okay, and it is very popular among data scientists to write queries. Right, in SQL you write queries, right, which will give you some output and all that you can do with this. Okay, then this is your data frames where you typically focus on what is your you work on tabular data, right? It's very similar to your pandas. Actually, you will write a SQL query, you will give a query, and no matter what data format you are reading, CSV, JSON and all that, you'll get a tabular format of data, and you can write any query, join.
We have worked with Tableau also. That also you give some SQL
query,
and give some Java.
Right, that sort of thing. Okay, the fourth part is we'll learn what is streaming, but basically we'll focus on structured streaming only. Okay, because that is what is new, and a lot of companies are migrated toward that way, machine learning. So this will very much depend on what is your current understanding of machine learning. Okay, it might be a brief introduction if you're not aware of that. Okay, but if you're aware of that, I can go a little deeper. Okay, then how do you deploy Spark application? Create a egg file in Python, right? You'll create an egg file, you'll copy to the server. How do you do a Spark submission job, right? That way you can do. This is the entire flow. And I mean, there are a lot of projects that is mentioned here. We'll do a couple of them from here, like click data analysis. This is what we do with streaming. Then predicting birth survival, predicting whether this is a machine learning problem, predicting whether the person will be survived or dead. Bank data analysis using pandas, you'll do predicting insurance amount, right? Food review sentiment, right? Not all the projects we do with every batch, but at least few of them will be doing it. Okay, so let's now understand how does Spark basically works. Okay, the Spark architecture is pretty much like this. Okay, you have a master node, you have executor node. Okay, in master node you will be submitting the process, the application.
Then it's same with MapReduce only.
Yes, the architecture wise it is very same as using MapReduce, and you have the executor. Yeah. This guy actually converts a job, whatever application you want to run, into task and sends it to different executor. This executor can execute in a parallel. Okay.
The same job the MapReduce also will do.
This architecture wise, cluster distributed computing wise, it doesn't matter. It doesn't really change. You don't need to change. This is universal.
The estimated time and the code you require, that is different with MapReduce and Spark.
Right. Okay, and absolutely. So Same.
So as like MapReduce, the master node will connect to
Dictate
the
that.
slaves and it will divide the work among the other nodes. The
Same way it will happen. Okay, and remember what is Spark? Basically, Spark is a compiler. Whatever Spark module it works, right? Okay, I understand it is a deployment environment, but first thing that it does, it compiles whatever code you write, right? It will compile it, it will translate into something like lineage, like this. Okay, these are like, this is what Spark low level framework understands. So whatever application level program you write, it has to convert it into this format. First thing that Spark does is converts your code into something like this. Okay, so that is one thing. So Spark converts whatever whatever high level code you write to some low level components, and this is what the machine executes. And the beautiful part about these components is this supports parallelism. Understood, right? You write some code, Spark will do the translation of the code. On doing the translation of the code, it can execute in, it will be making use of distributed environment to execute your stuff.
But we don't get the resemblance of that noded graph, right? Like if you give some code, you get the output the same or different?
Same or different output based on different code. Okay, but you will see such visualization. Okay.
So we get the same visualization.
Same visualization. Yeah. I mean, if you want to say internally how it is generating and all, you can see this data. Okay. Now the thing is, okay, this is the resilient distributed dataset. It's like heart of your Spark, right? Hi Himanshu.
Hey Vante, how are you?
I'm good. How about you?
Good.
Okay. So okay, so let's understand what is your resilient distributed dataset. Okay. Resilient distributed dataset is the core element of Spark. What it does is whatever code you write, okay, it will I mean and whatever data you have, okay, whatever code you write will be working on whatever data you have. Okay, now your data is of course spread across multiple machines. Because the basic problem that Spark is trying to solve is distributed computing on distributed stored data. Right? If the data is broken down into smaller pieces and stored across different machines, okay, how is distributed computing happening? This is the problem that Spark is trying to solve. Got it, right? You have 10 nodes, okay, and like this, right? Okay, this is one node. Okay, so you can use some piece of data is here, some piece of data is here, some piece of data is here, some piece of data is here. Okay, so you can use distributed computing of Spark, okay, to do parallel computation across this machine, across this machine, across this machine, across this machine. So what is RDD? RDD is a virtual representation of the data which is spread across multiple machines. Right?
How does that work?
Yeah. So actually, whatever code you write, that code will be working on RDD. Okay. And what is RDD? RDD. Suppose some data is here, right? So RDD is actually pointed to this, pointed to this, pointed to this, and pointed to this. Okay. So that is why it is known as virtual object. And
It acts like a master.
RDD is an object. It is not a node. It is an object. It is. I mean, see, there will be many data, right? This is another piece of data. Okay. There is another RDD which points to this new other piece of data only. Understood, right? So RDD is not that it will point to all the data. It will point to some section of data which you want to work on. currently. And whatever operations you are doing on this RDD, add all the data. You'll do on this RDD, multiply all the data, this RDD. So all the data that it is pointing to will participate in the action. Okay, so understood what is an RDD?
Yeah.
RDD is this basic element of Spark. Okay, the reason why Spark is popular, Spark is popular is because it's ease and fastness. Okay, and why both of these is achieved is because Spark does all the computation in memory. Okay, Hadoop does all. There is multiple times file system read and write access that happens in Hadoop. Okay, the Spark actually do not do that. Spark actually keeps all the data in the RAM as much as possible. It uses advanced memory sharing, memory optimization techniques, so that you don't have to move out data. And as long as data is there in the memory, it is giving you good accuracy, good performance. Understood, right?
RDD has some two set of parallel operations, transformation.
Okay, that is the no. So RDD is a huge topic. Okay, that means we'll invest 40 to 4 hours on RDD. Okay, so what is RDD doing here? RDD, okay, let's first create some RDD. Okay, then I'll explain most of other things. Then I'll come to other concepts as well. Okay, let's first see, think, understand what is RDD doing to us. Okay, so I will explain my environment. I am running. This is my AWS account. Okay, and I have installed PySpark here. I'm installed Jupyter Notebook here. You can do it in community Databricks if you don't want to have a AWS account. Okay, and I'll be writing my code over here. So this is my stuff. So
we can write there and we can compare there only.
We
can
run there itself. Okay, so okay, so there are two ways to create RDD. All these notes are available in the GitHub. Okay, there are two ways to create RDD. One is parallelize, one is text file. Okay, parallelize means it will try to create an RDD from collection. What is collection? You have a list is a collection, right? It will try to create an RDD from collection. Okay, and once you have RDD, it will be like a virtual object which points to all the data. Then you can do all the operation. So for ease of creation and all that, we'll try to do that many times. But in production, this is not something that is used a lot, because collection means data is anywhere in one system. If your data is anywhere in one system, then anyway it doesn't matter to have RDD. RDD is more useful when your data is across multiple systems, so that you can do parallel computing. Fine, right? Okay, so this is parallelize, this is text file.
So that is creation of RDD.
Right. Okay.
We have to create an object when we are doing this. So
let me explain. Okay, so RDD creation from collection mostly for learning and debugging purpose. Okay, so what you are doing here, you are actually say here two things. When you see, I am doing this SC dot. SC is a inbuilt object in Spark. Okay, SC is known as Spark context. Okay, SC is like a handler. SC handler to Spark. Framework. Okay, so what is it doing? SC dot parallelize. It means you are using Spark handler parallelize, and this is the list you are passing here, and this is the number of partition. So what you're doing in this line, you're telling it that create an RDD, okay, from this data 1, 2, 3, 4, 5 list. That is what the purpose of SC parallelizes. Okay, and comma 2 means create 2 partitions of it. Okay, what is create 2 partitions of it? Because you want to do parallel computation on these 2 partitions. If you don't give here anything, it will by default pick its own number of partition. Okay, since you gave here 2, it will find out 2 partitions.
2 partitions it will do, and how many elements it does take in each partition?
That is up to the hash partitioner algorithm that is present here. Okay, that means we can control it. We can see that, and we will see that we can control it. But here the major thing to understand is that because it giving some data, it is creating 2 partitions out of it. Okay, and what is this RDD? This RDD is an object. Okay, so RDD is a virtual object which will point to data across 2 partitions. And remember, both this partition here can live in the same machine. Okay, then this is your creation of RDD. Then you have come across map in Python. Map filter. Right? Map RDD map. Map means it will take each element of this guy.
Data set which you have given.
Right. Each element of this, do the translation that you are showing here.
Yeah, I remember that.
Right. So it will take this one and do this 1 into 2, and it will return. So finally, if I execute this is known as transformation. Map transformation. Okay, that means that is it changes data from one format to another. Okay.
It will take the data set which we have given, and it will perform the operation and produce the that is happening.
That is happening. Few things you need to know here. It will not execute until you this collect, right? This is the action.
That is the default one, or we can change it.
Then a lot of other varieties are there. I'll show all the options. So what is transformation and what is action is transformation will not be executed until there is an action that is associated with the pipeline. Okay, until you call collect, it will not execute map, this function. This is what is called lazy loading concept of Spark.
What is that?
I'm explaining. Okay, until action is connected, transformation won't happen. Okay, until action is connected, transformation won't happen. Okay, and this concept of delaying execution is known as lazy loading. Okay, so this is a very important concept because Spark is a very smart compiler. It tries to create for you the super optimized code. Okay, no matter how bad a code you write. Okay, so it actually reads it when you call action, right? It can't wait anymore. It has to start executing, and it will not start till you call action, so that it can read your code and see what is the best way to generate more code out of it. If I write you some Spark code, you write some code. Suppose you write better code than me, but Spark will take care of it, so that it generates optimized code even for my code, which is not so good, and our code will be performing the same. Okay, this is right. This is possible because of lazy loading. Is
this book only for the students of here, or
anyone can access it? Till Spark control reaches action, it can decide best way to create execution. Understood, right? What is collect? So let me execute our first code here.
For running the code, what should we
Shift enter. It's a typical notebook environment. So you're executing shift enter. So, right now you want to see how many how many elements are there in the RDD. Okay, you can see here 2, 4, 6, 8. So you can do count, prints the number of elements in the element. So remember, it can actually point to multiple locations, right?
And also we have given the partition also.
Right, we can see what is it. We can see that print return number of nodes across number of data pointed by okay. So now if you do RDD dot
Okay, for writing the code, we have to click insert and we have to give.
say insert, I mean in middle of it. If you're writing in the bottom of the page, then you just do shift enter, it will create a new page. You can see here glom. So this you can see here 2 partitions you have created, right? This is the data for one partition, this is the data for another partition.
Yeah. And it took automatically like first partition with 2 elements and the second partition.
Right. Glom puts data of different partition. Understood, right? What is Tom doing? I think I could restructure some sentences. Okay. Now we'll see how to do the same thing for CSV files. Like generally that will be the case. We'll be loading some externally available files.
Only CSV and direct typing or
any type. It can read any type of data. Okay. So here I am passing CSV and it will read later like sc.text file. It is reading the CSV file. Okay. So what it did do? It created an RDD out of it. If take 5 minutes, it will show first 5 data.
How to upload any CSV file from our system?
You can in Databricks. I'll show you. Okay, there is a data module where you can upload. Okay, you have AWS account. Don't have AWS account, and okay, I'll show it in Databricks how to do it. Okay, first you try the other stuff. This guy there is in Databricks. If you here I have right. This is a Databricks environment, right?
In AWS, we don't have any free account to create.
Free you anyway have to. I mean, my bill comes some I don't know 100, 150 every month.
Yeah, because we have to pay.
Yeah, it's a Linux machine they are giving, so still charge. Okay, so here like if you click on this data. Okay, this is free, so you can select the file that you want to do. upload file you can do. Okay, mention the path here. It will create the path and you can use this path for loading the file.
And for direct creating the program,
program here, right? If you have to create a program, do a notebook, Python, and prior to that, what you have to do is you have to create a cluster here. See this process now. Create cluster.
The same like a GitHub.
So first you have to create a cluster. Cluster is like you're creating actually a cluster. Okay, Zeek is the name that it create. So now if you see cluster is there, convert it to Python. Right. So here you can write the code. And whatever file you create from there, the path will be available here directly. sc dot. Do this exercise at home today. Let me know if you face any difficulty. Okay. So returns first 5 entries.
It will take only from the first state. Here we are telling it will get only the first 5 entries.
Right.
Like you can't get in middle or from the last.
You can get it. There is something on the sample. You can then random some data.
So if you want to get first 5 and last 5, then you have to give double 5 or not like that.
No, you have to merge them both. Take first 5, last 5, then combine the results.
Okay.
Or you can write some condition inside it so that only those.
Now, how we are getting this first 5 entries? Just by using the take 5.
Take 5. So it does not understand that the RDD does not understand what is the data. So this is treating the first column name as also one data. This is just reading line by line. If you see the CSV file, right? Forget CSV. It is just it doesn't understand CSV as of now. Okay, then we have higher layers like DataFrame APIs will understand CSV file directly. This guy text file do not understand, so it has to do the processing all by itself. So see, it is treating the row name, column name as also one row. Okay, and the other things as well. So it is giving you this data. First, you have to load it. Fine, right? In case you forgot what does the argument take, what you can do is you can do just help. I think it takes a ratio 0.01 sort of a thing we can pass. And see, sample, the first parameter is with replacement false. Second parameter is fraction, how much amount of data you want. Okay, among the entire data, how much data you want. And third one is seed. Okay, so first is false, 0.01. You can see here 0.01% is this much amount of data. Okay. 484. Okay, so it randomly shows this amount of data. Randomly chosen.
We can make any updations also for existing code, like inserting, update, delete, or something like that.
Existing code.
Like already now you have one data set, one you want to add one more or two more elements to it. So,
you can do that. You can add one column to that.
Yeah.
We learned it in DataFrames, how to add columns to a Spark data frame. Randomly chooses 0.01% rows from the pen. Okay, then I'm again. This is the code that we have seen before above as well. This is the same code, right? It is actually
but the lambda function is
changed. I don't need it here. Okay.
And what about the partition? It didn't happen, no? They
No, we didn't call with partition, right? I didn't call glom. Glom will show the partition. It will show all of them.
we just have collected.
Collected, yeah. Okay, so I think we don't need this is a repetition of the stuff, right?
But with a different lambda function.
That is anyway the same message. Okay, now we'll have this is first type of RDD. Okay, now we'll have another type of RDD which is like paired RDD. Okay, just give me 2 minutes. I'll be back. Just do RDD dot and you will see all the options present here. Okay, so we learn almost all of them. Okay, and try to see how to make use of them. Okay. Okay, so this is all. Let's take one by one. And before we go there, I just wanted to show one more type of RDD. One is what you've seen is RDD from collection. Okay, one you have seen RDD from text file. The third RDD is RDD from pair data. So what you see here is pair data. This guy is there, this guy is there, this guy is there, this guy is there. This is pair data. Okay, this guy is pair data, and you do sc.parallelize. Okay, when you do this, RDD pair is equal to sc.parallelize. Okay, what are you doing? You do this. If you just dump it, right? What you're doing here, you're seeing a regular RDD. Okay, but pair RDD is very important to understand because a lot of your data will be in this information. I mean, if you have name, location, right? Lot of this will be acting as a key. This will be more information. So lot of I mean, just to understand like this. Okay, if you do count, it will tell you 4, that sort of thing. Okay, so we'll use this pair RDD to do a lot of stuff. Just keep in mind that this is something known as pair RDD. Okay, so now we had a previous RDD that we have seen above, right? Let's see. Insert. If you do RDD here, correct. Okay, so you have these numbers here, as you can see. Okay, so when you do RDD map and you write this lambda str plus x, so it will add hello to each of these words. Right? If I do correct of it, it will print 1, 2, hello, 3, hello, 4, same stuff as you have seen, right? Just that a little more different lambda. Okay, so not only this, I mean, this is just to understand how does lambda function basically work. You can have a alternative regular function f, which can be a multi-liner function. Okay, let me execute it. Okay, now the thing is you don't see here the prints happening. Okay, so and you don't see, you need to know what is the I did remember I told earlier that this will be generated. I told earlier that a lineage will be generated internally maps, but you need to see that, right? Okay, to see that, what you have to do is we have to see the port number on which it is running the web UI server. So
this we can't see from Databricks, right?
No, this you can see in Databricks as well. Just click on the arrow below, you will be able to see. Okay, I'm just looking for the port number. It's generally 4050. Okay, let's see. Hmm, 4040. Okay, so you can see, I mean, this is the production environment. You will have a server, you're running PySpark there, you will be able to see this. Okay, so now this is the function that we ran just now, right? Count. You click here, you see, whatever has happened over here. Okay, and if you want, if you want to see DAG tag, and if you want to see what all things is executed inside it, click here, tag visualization, and see here, count function is getting executed, right? Right, count function is here. If you want to see more, how much time is it taking, all those things you can see it here. Okay, then how much storage is concerned. When you do caching, right, you will see storage information also. You understand what is caching? Caching is like to prevent bringing data from your file system. Rather, it is a memory performance improvement technique. Okay, I'll explain it when I go to caching. Okay, so here, you can see count function is there, right? That is a count. We are seeing it there, and you can see here the RDD.
What it is counting?
See here, it is not here. If I do this, RDD is equal to RDD map. So actually, in earlier case, if I do here in this case, it is not actually executing this function at all, right? Because this RDD is created, RDD map I'm doing. Okay, after I'm not doing anything on this RDD now. Okay, I'm not doing anything because whatever. So what do you do? Okay, then actually it will execute this. So how do you know that? Okay, let's proceed.
I didn't understand the program.
This part. So this part is nothing but it is just taking. I mean, just I'm replacing lambda by either I do it like this or I do it like this. It will eventually do the task.
No, that is fine, but there we are given L is equal to range of 100. And we didn't give any count function or something. We have given RDD count. What is counting?
Number of elements in the RDD. Okay. So range function will generate you number between 0 to 99, right? It will put inside. It will create an RDD out of it. Okay, and you are seeing the content. Okay. Then we'll understand. This is very similar to that. We'll understand few more things, flat map and those things also there. So now we'll see filter map. You have this data. L is there, right? L is your range of numbers. Okay. First map creates. So this guy, you are creating an RDD first. You're chaining everything in one line. Okay. This is creating an RDD first. Then you are applying this map function. Map function will add 2 to each of the element. Okay. Then filter is there. This will be selecting the data out of it. So filter function is actually selecting only the even number out of it. Okay. Then you have map. Okay. What is this map doing? Map is converting whatever is the finally selected data out of here. It is adding a string num to that. Okay. Then you are doing a collect.
Yeah. Then the final collect.
Then the final collect. Okay, so understood what is this filter. Let's see. Okay, now let's see what is flat map. Flat map, yeah. Does 1 to n mapping. Say you have a data which looks like this. Four, five, six, seven, eight. Oh, sorry. 4, 5, 6, 7, 8. Sorry. First, you have to create an RDD out of it, right? RDD is equal to sc dot parallelize data. Okay, so it has created a RDD out of it now. Okay, now you do RDD dot flat map. Okay, and you pass here each of these elements. Okay, lambda d. Okay, it returns a data d comma d plus d into d comma d into d into d. Correct. What will collect do you know? Collect, though I have used it multiple times, but really I haven't spoken much about it. Collect, actually, all the data will be generally in the different executor machines, right? Collect will bring data from all those machines, different executor machine, and bring it in the driver. Okay, so this is generally not a good practice. Okay, just for showing, for learning it, we are using it, but generally collect is not a very common activity that you will be doing. It is not a, unless the data is really small, you won't be doing collect. Okay, because collect will bring all the things to the driver. You don't want the driver to comma, right? If I do this, okay, see what is it doing here is it is converting this 4 into 4 square 4 cube, 5 into 5 square 5 cube. So 1 into map was like 1 into 1. This is 1 into n.
Okay. But in the above program also we can do this, right? Without using the flat map.
We just map. If you do this, I mean, definitely RDD dot map. Okay, and I suppose I write the same function. It will give you a list within a list.
Okay, thank you.
That will be the difference. Understood?
Yeah.
Clear so far? Let map this line. Okay. Now let's see one of the most important concept, that is caching. Okay. So now let's understand what does caching do basically. Okay. Caching basically see when you are doing some computation, right? For example, you are creating an RDD like this here. In this line, you are changing the RDD, adding using map, right? Each element you are adding 2. Then in this line, each element you are adding 3. If I don't do caching,
It will do the repetition
process. Right. Okay, if I don't do caching here, it will recompute it. That means it will start from here, it will execute this guy. It will, right? So caching effectively means you are trying to, rather than removing from the memory just because you are done, your developer is telling to, let it stay over there so that it doesn't have to recompute the thing. Exactly. Okay, that is why a good developer and a seasoned developer will do these different things. Actually, they will cache the data in a proper way. Okay, so that your performance, and how do you know how good is your how? Suppose if I don't do caching, remember this data is small. I don't know if I was able to store a lot of. What I can do is I can take a large data. Okay, now if I do in storage, see there is no data that is getting cached. Okay, and if I do in job, I think it is taking it some 65 milliseconds now. So let me add some caching here. I'm adding two caching. One is it will not recompute this RDD, or rather I don't need it anyway. I can directly cache it here. Okay, you remember 65 milliseconds, right? Increased. This is, see here, you can see here this much amount of data is cached. Okay, this much. What is the caching memory? What is the information? You can see here everything. Okay, and if you see jobs, it should ideally be lesser time. Sometimes it doesn't. Let me just clean up something like this line. I don't need. This is 25 milliseconds now. Okay, so now if I do this caching, can you see the difference?
Yeah, 0.1 seconds.
It is actually taking the layers, right?
If you give caching, it should reduce the time.
I'm doing something wrong. Okay, so if I do this, RDD is equal to annotate. If I RDD.count, actually it will be same thing in both the cases. Acha. So let me do this. RDD1, RDD2.
Okay, because you have given the same object name, that's why you are getting that.
Let me just see, because I think it was working earlier. Fine, I think I was doing some changes in it. So RDD, it is creating a parallelize operation. You are doing a caching here. Okay, RDD1 is like RDD map. It is doing this operation. This guy is dependent on. So if I do. This is Acha, sorry. Yeah. So what will I do is, so now I want, whatever I want to test is, if I don't do caching right, it will try to create that RDD every time. Okay, if I do RDD.cache, it will not recreate the RDD. Okay, so if I am doing that, RDD.map, RDD.map is this data, and you want RDD.count. Okay, next time when it is, yeah,
There RDD2.count.
right, print, and in the next line we'll do print RDD2.count. Okay, so what will we see is first time it is this first this is whenever this is one job. Okay, this lineage will be one job, this lineage will be, we will see first time it is taking more data, more time, next time it will take very less time. Yeah, that is how we compare. Okay, so go here 24, right? 20 or 26. See the first
Down.
a little strange because there's something. Am I doing the reverse? R2. Oh, yeah. Now it is right. Okay, now it is right. You see, first time I gave it accidentally one, so it is again recomputing one test. Okay. Okay, see here 27, 28, yeah, 83 and 68. Yeah, because it's a very small amount of data, and it's sometimes tricky to show it. So that's how you see it. Okay, so caching is a very important thing. I mean, so you can there is this caching, and you have the use of persisting also. Persisting, I mean, this is like saving in the memory only. You have another API known as persist, with which you can save half of the data in the RAM, half of the data in the file system. Okay, that is your persistent. Okay, so if you see now, if you see the data is not removed, it's there. You want to remove this data, right? What do you do? Okay, after you've done both the operation, okay, you should be doing RDD dot unpersist. Okay, actually it created a new one, then it has deleted now. The previous one it is cached. Understood, right? See, earlier if I execute that program, it created me a new job, like if you see jobs here, right? 30, 20, right? So now if I if I earlier execute this code, it should create a new entry, right? You will see here it is not getting created on the previous ones.
Because it's
already been unpersisted actually, and you can see here earlier it was taking 70 data, this is taking 59. Understood, right? How to unpersist? Unpersist is for removing data from caching, but you need that RDD context to do unpersist, so make sure you don't overwrite it. Okay, remove data from cache. Fine. Okay, now let's see some of the set operations. Set operations, as you can see here, what you're doing, we are creating one RDD1, RDD2, RDD3. Okay, so we are doing SC parallelize range. So what you are doing here, you are doing a Cartesian product. Okay, what you are doing here, you are doing a Cartesian product. RDD1, Cartesian, RDD2. Okay, collect. So you are doing a Cartesian product. Cartesian product of it. One guy with this and this.
If we want to merge now the two sets, then we have any merge. Now we are doing Cartesian product for both RDD1 and RDD2. We want to merge both of them then.
Yeah, we have union, all these operations here. So one is Cartesian, right? The next one is okay, all the set operations is valid here. Next one, as you can see here, is union. Okay, it will merge those operations, those data. Then you have intersection. Intersection. Okay, now understood, right? Interaction, union, you can do all the set operations are valid here. Now understand there is something known as checkpointing. What is checkpointing? Suppose your system crashes, right? You're doing some Spark operations on it and your system crashes. What will checkpointing do is it will try to make a backup of whatever computation is happening now, right? Okay. Pointing makes a backup of all RDD so that it can restore if system crashes. Fine, right? Okay, so let's pause it here. Okay, so what will it do? It will actually check whatever this data is there, right? It will checkpoint it here. Okay, let's pause it here. We'll resume from checkpointing. I'll upload this. Okay. You try, I'm uploading it. Git commit. Commit -m RDD. Okay, so you can see the code is updated here just now. Okay, let's go through this. Try writing the code. Okay, so that we can get into next stage.
So we have covered what is the Spark architecture, and why we use PySpark, and then RDD.
RDD we have started.
Operations.
Yeah, there are a lot of things in RDD that you have to know, understand. Okay, RDD is something to get 30%.
RDD also I have the notes.
Yeah, you have all the notes here in the GitHub. Okay, just click on the wiki section. Okay, so go here, RDD transformations and actions. This is like a summary of a lot of things. So what I've been doing is something cache persist, collect count. Okay, then have map, flat map, some set operations, right? Then filter you've done. We'll do combine by key on this things.
In GitHub, first we need to create a cluster, then we need to.
In Databricks.
So,
Yeah, let's just create a cluster. Then let me know if you face any difficulty. Okay, if you're stuck anyway, just Google. It's pretty much. I mean, it's very easy as you saw me doing it, right? That's much it. Okay, later on I'll explain how to do in AWS, how to run it in cloud.
So this much for today.
Yeah. Okay, Himanshu, let me know if you have any doubts. Okay.
Okay. One thing, the session will be at this time only every day.
At least few days it will be this time. After that we can shift because there is a batch in the previous time. Okay. Few days let's manage. You can plan it on weekends as well. Okay. And in case, in fact, we'll have it tomorrow, and after that we can have it on weekend. I think both of you will be fine, right?
In the morning.
Okay. I'll keep you guys posted.
Okay, cool.
Sure.